Hey guys. Thanks so much for coming this afternoon. I know it's been a long day for some of you. Really appreciate you coming to join. I think this is a really interesting and important one, which is why I built a talk about it. So hopefully I can help you out with wherever you are at your journey on the multi-account adventure. So basically, when you start out in an enterprise, you'll find that these companies are at different levels of maturity with how they organize and choreograph different teams and different accounts with their cloud footprint. And so what we're seeing is that there's a lot of confusion about how best to do this. And so over the last sort of 2 or 3 years, we've had a lot of work done globally on how we can come together and build up some best practices and advice on how you can set things up the right way. So that's what we're going to cover off in this session. I'm going to run you through some best practices on setting up your deployment processes and DevOps tooling across accounts. And I'm going to run you through a little demo that we've got to show you kind of how it works mechanically. So what we do see this conversation often arising from is it comes from challenges that people are having. And the first one of these is generally coordination across teams. So when you're in a big enterprise complex environment particularly, coordinating your applications that are connecting to other applications in the company is complicated, and then working with the teams is hard. Coordination of deployments getting rolled out, coordinating with other teams on time slots, all of this stuff is quite challenging, and this is something that still happens in the cloud if you don't orchestrate these things the right sort of way. There's also environmental complexity that comes to play. So when you've got these different systems that are interconnected, you don't want to break other people's systems or interfaces with your deployments, and so orchestration becomes really challenging. And change control processes have a tendency to slow things down. And so in the modern world of agile software development, we're trying to find ways that you can take out some of the blockers. And having multiple accounts is a way of segregating things and ensuring there's a security blast radius that's contained if there's ever a compromise. But at the same time, if you need to push something out to your dev environment and then promote it into your test environment, and then you've got multiple test environments, and then you've got multiple teams interfacing with those test environments, this becomes really hard and it can slow things down a lot. So these are some of the challenges that we see quite commonly. So when you're starting out, it usually starts with a proof of concept or a small project, and it might be one DevOps engineer or developer that just starts building stuff in the cloud. And that generally follows, if it's successful, with adding a couple more environments. So usually what happens, we see people spin up another VPC within the same account as the existing dev VPC. And then for production, we see people really commonly making a good decision, which is to isolate that production environment in its own separate account. So that's good. Then once companies start maturing their practices, generally we see people trying to get some sort of isolation. You've got a little bit of maturity in the way you're doing your Terraform or your CloudFormation. You start breaking things out and you realize that you can stamp out these different VPCs into different accounts pretty easily. That's a direction that we're seeing things sort of trending. But what do you do with the pipelines? What do you do with deployment? Well, one thing we see quite commonly is the pipelines getting set up within each of the different environments that you've got running in the cloud. And that's commonly done because as an engineer, you're generally just trying to get something done to get your dev environment automated so you're not doing all the manual processes. And that's a good intent, but then when you want to roll that out in other environments, often people will take those same sort of scripts or configs and then push them into those other environments. Problem with this is configuration drift. So if you define a pipeline, you've got a bunch of different steps in there that you've spent a whole bunch of time defining really carefully, and it works really well in that environment. And then you push it into a different environment. A lot of the time, there's a bit less diligence over making sure that it's consistently applied in those environments. So the scripts tend to take a path of their own, even if you are using infrastructure as code to define these pipelines. So there's a bit of a risk there that pushing those pipelines into their own different environments is going to cause your configuration to drift, and you're going to lose control over making sure that the pattern that you use to deploy in your dev environment is exactly the same as your test environment, is exactly the same as your prod environment. So that's one of the challenges we see, and it's very, very common, the multiple pipelines pattern. So iterating on that, some people see this issue and will build a single pipeline that spans across the accounts. Now, this is a great thing to do because what it means is that in a single view, you can see which exact phase in your deployment pipeline code is getting promoted through. So if it's getting pushed to your test environment, you can see what steps it needs to pass to get to prod. So that whole process is visible, and it's also good because you're not going to have configuration drift to the same extent. You can make sure that the pattern that you're using to promote to dev is applied consistently to test and to prod. So that's a good thing. Now, the challenge with this approach is that you are, as you can see there, you are hosting your pipeline in one of those three environments. So you're kind of coupling your pattern, really the configuration of how you manage your change, which is what a deployment is. It's just change management. You're pushing that into the context of your application. So if it's hosted in your dev environment, what does that mean about your security profile when you're pushing stuff from dev into prod? I would say it's problematic. So what we're starting to see more and more customers do is build out a pattern that looks a little bit more like this. So you've got, in this one, you can see an account that's completely dedicated to the DevOps processes and tooling, and then the application environments have accounts of their own. And this is a great pattern that we're seeing a lot of success with because it's keeping everything separate and isolated and well-defined. So what you can do with this is you can define exactly what security parameters are required to push stuff into your dev environment. And if you want those security parameters to be different for test or prod for any other reason, you've got full control over that. But this is a good way forward. And the other thing is, it doesn't need to be just your DevOps pipeline. Any other DevOps tooling that you use across different environments can have a similar pattern applied. For example, one thing that we see some people doing is, particularly newer cloud-native businesses, is using tools like the Simian Army. For those of you that haven't heard of it, Chaos Monkey is a really famous tool for doing chaos engineering, which is introducing randomness into an environment to test out the durability of the infrastructure. So you could, for example, run Chaos Monkey script in your dev environment. You can launch them from your DevOps environment, push them into dev, and then if you're comfortable that the way that you've got your architecture configured in dev is durable, and by trying to randomly shut down servers or kill networking connections, it will continually bring itself back alive, it'll self-heal, then you can push that to test and try that out. And ultimate would be running your chaos engineering practices in prod, which is making sure that you are super confident that your production environment is alive and durable and happy. So that's great for a single team, for a single application, but how do you handle that when things get a bit bigger? Well, that's what we've seen more and more people trying to achieve, rolling out patterns like this at scale. And this diagram captures a really good way of achieving that. So you can see there we've got these enterprise-wide accounts. Now, these will generally be managed by, say, your Cloud Center of Excellence. And the COE might have, they might look after, for example, connectivity, networking account, and shared services, but you might have InfoSec managing their own security account that they use, and those tools might pull data from different accounts all across the organization, for example. So those enterprise-wide accounts are generally centrally managed, either central IT, Cloud Center of Excellence, InfoSec, teams like that. The developer accounts are something that can be provisioned out for everybody as sandboxes. and you can use policies to define what those accounts would look like. I'll touch on that shortly. And the business unit accounts is where you've got the pattern that I just described before. So that's where you'd have your DevOps tooling and dev test prod for each application. And you might use those accounts for multiple applications, but within single business unit. So the marketing team might have their own, the marketing engineering, or your operations engineering might have their own pattern like this. So this is happening because customers are getting to the point where they're not just spinning up 3, 4 accounts. We're seeing people spin up tens, dozens, and even hundreds. So you need some way to plan for this and to manage it, and we're seeing a lot of success with this. It makes things a lot simpler. But the big question is, how do you actually achieve it? So to be able to do something like this requires a service that we've got that was released a while ago now called AWS Organizations. And Organizations helps you deploy out multiple accounts, and it gives you the option to use policies to define exactly what is enabled and what is not enabled in those accounts. So the first one of these is the ability to control those AWS services. So you can say that in this account, Elasticsearch is available. These set of accounts, we've got a different policy. So for example, we want to disable Elasticsearch to be deployed out across all of the developer sandboxes. But you can choose for the business unit VPCs and accounts, you can say that everything is available, but you can have the central IT reporting back to what sort of services are being spun up as well. And you can mandate that certain services are available or not. Really important feature is the ability to automate account creation. So that's one thing that Organizations does, which is pretty critical if you're going to be doing the developer sandboxes at scale. Really important one. And then the ability to do consolidated billing and usage reporting as well. So this area is complex, and it becomes more complex trying to assimilate all of that information at scale. So having something like AWS Organizations is very important for that purpose. So there's 2 ways that you can go about actually technically doing this. So Organizations is the first tool that you'll use kind of no matter what, because that helps with the account part. But AWS Landing Zones is something that we released just a couple of months ago. And the landing zone is it's a solution, it's a pattern, and it's also a CloudFormation template that lets you get started if you do not have a big multi-account pattern already in your organization. So landing zones is basically an easy to deploy solution that it just sets you up so that you can do all of that automated account provisioning. It's based on best practices that we've seen. This has been built up over the last 2 or 3 years, so it's not just AWS kind of making it up. Like most of our services, it's stuff that we've had a lot of demand for over time, and we've taken that on, and we've learned from what does and doesn't work, and we've set this up to try and guide you and give you guardrails to make sure that you don't make mistakes that others have before. It gives you the initial security setup and governance controls that you need. So it gives, for example, one of the important parts that's listed there is automated deployment, but it sets up all of the governance around how you can define your policies that are used to build out these other accounts. It lets you baseline accounts, and it gives you that concept of an account vending machine where you can just churn them out as required, and you've got controls so that you can spin them down as well. So this is a really good starting point for implementing a multi-account strategy. So you can see here that we've got a couple of different accounts. So the Organizations account, parent one, is there at the top. There's a shared services account, a logging account, and a security account. And we've got a bunch of tools in there that I won't run through in detail that should give you a feel for the different services that are deployed automatically as part of this to help solve the key problems that we see people having when setting these things up themselves. So this is publicly available. You can just jump on and download those scripts, and it'll give you a really good head start. But if you're already in a position where your organization has a bunch of accounts already at play, and you need to start sort of wrangling them together and exercising a bit of control over that, then the other option is just to roll your own. So we've got a bunch of different tools available, as you would well know, I'm sure. CodePipeline is what we use to orchestrate a lot of the different elements of the DevOps tool chain. And then, of course, you can roll any of your own from Marketplace, and there's a wide range of those available. Now, one important tool that is going to play a key role in doing this stuff is Systems Manager. Now, Systems Manager is really great for orchestrating a whole bunch of different activities across a server fleet. But for the purposes of this session, we're just going to have a look at Parameter Store. Now, Parameter Store is something that helps you apply the 12-factor best practice of separating out your code from your config. So you can use that to store your secrets, and if you've got connection strings and things like that that you need to store somewhere, then Parameter Store will do that job. Now, my friend Aurelian and Paul have a session after this. If you want to find out more about Secrets Manager, which is another option that you've got available, then they're going to be running through that. They're using both Parameter Store as well as Secrets Manager. But essentially, for our purposes, it's just a very simple place for you to store secrets that you can then use as part of your overall multi-account setup. So the little demo that I wanted to run you through is called Docker Invasion. So there's a QR code there. You can go and hit that right now if you like, and you can have a quick go. Now, it uses two microservices. We've got ECS and we've got Lambda. The game itself is running in a container, Docker container, and the TopScore service is running in Lambda. So I was just going to run you through what the flow looks like for those two different scenarios quickly. So for the game service itself, the way that this works is a developer will check in the code to CodeCommit, and then that will get picked up by CodePipeline. CodePipeline will then trigger code build as the next stage. Code build will build the Docker container based on the new code that you've checked in, and it will store that container in our Elastic Container Registry. So I know that we've had a few Docker sessions today, different container sessions. I'm sure this has come up. ECI uses S3. It stores your information, it stores the build artifact in there, the Docker container. And the way that it works, and this is the key part, CodePipeline, or whatever your tool chain is, your pipeline tool, will assume a cross-account role into using IAM. So when it does that, it will then push the CloudFormation script in. That CloudFormation script has the details of the difference in ECR of what container it needs to spin up. ECS will then get, that change will get pushed to ECS, which will then reach out to ECR, and then it will pull that container out and deploy it onto the EC2 instance that the container is running on. So that's the game service. Now, at this point, we've just deployed to dev, and that's great, but we probably don't want to just ship stuff out the door to production. So what you need to do is make sure that you've got a gate set up to ensure it doesn't just flow straight through, whether there's passes or fails of tests. So there's a few different options. One that's commonly used are black days, where you have a gate that says, do not continuously deploy during these particular time windows. That's often if you're like a software as a service retailer, like online retailer, you might want to not deploy during 9 a.m. and 10 a.m. each morning, for example. Other options are you can gate it by just having a simple manual approval step, and that's what we've got in our demo. And then a few other ways that you can do that as well. But the important thing is that you've got the exact same pattern happening, where a cross-account role is assumed into production, and then it will push the same pattern through, deploy the CloudFormation script, retrieve that build artifact, and then push that out to ECS and EC2. So that's the game service. TopScore service we've got is a little bit different. So similar pattern in that you check your code in to get that picked up by the build pipeline that then processes that and writes the artifact to S3. Now in our case, that build artifact is a Lambda function, and the Lambda function needs to get pushed into those two environments. So CodePipeline will then assume a cross-account role, make the change to CloudFormation, push that in. CloudFormation will then retrieve that build artifact and push it to Lambda. So in our case, what we're doing, I wanted to show you was how Lambda will use a different connection string for the DynamoDB endpoint in dev to the DynamoDB endpoint in prod. So it will retrieve that from parameter store, that endpoint. Same thing happens when you're going into production. Of course, you want to have some sort of gate in the way, but as long as the gate's there, you can assume the cross-account role and then push it into CloudFormation, retrieve the right parameter when the function's executing. So I've recorded a little video to show you exactly how this works. Can we switch across, please? Thank you. Okay, so what I'm going to show you here is the app itself. For those of you that scan the QR code, you'll see this. It's a little Space Invaders clone. Pew pew. And so from there, we're going to jump straight across into CodePipeline in the console. CodePipeline, we've got a few different pipelines there. So the one that we're looking at, as I said before, is the ECS one. So we've got a source stage where which will get picked up when we commit stuff. We've got a build stage where we're using AWS Code Build. We've got a deploy to dev stage and deploy to prod stage. So you can see in there, that's where we've got the manual approval listed. So that's our gate that we're using to make sure that we get the right thing into prod. So this is the code that's running, that we're going to be running in our container. So you can see in here, it's just a little JavaScript app. So I'm just commenting out the background color and putting it to something a little bit more interesting. So we're just going to add that to the change and commit it. Bring the party. Now we're just going to push that in to the repo. So you can see that this is my internal private CodeCommit repository. Okay, so now that that's been pushed, that's going to get picked up here in the pipeline automatically. So you can see that it's being picked up at the code commit stage and processed. Now, while the build stage is occurring, I'm just going to show you what that looks like, the build definition. So this is code build, and you can see we've got the repo listed there. And if you click on the project details, the build spec is listed. So that build spec is defined in YAML as part of the project. So you can see in here we've got the Docker build stage, and then a step to tag that build correctly. And that's tagging with what we're going to use for in ECR. And then the Docker push pushes that into ECR. So that means that the container, once it finishes building, will be stored in S3 there. So once that build finishes, it's going to deploy that automatically to dev. And then once that's done, it's gated by that manual approval step that we've got in there. So the manual approval is using workmail. So this is our managed email service. And you can see that it sent us through an email with the content to review, which is the staged version of our deploy. And you can see the background colors changed to something a little bit more party. So to approve it, you just click the other link. That pipes you into CodePipeline again. And it will come up asking you to approve or reject the revision. So this is the manual approval step to make sure that the right content is getting through to production. So this is an excellent pattern. And as I was saying before, you don't need to use CodePipeline. All of the commonly used DevOps toolchains will support these features. So now that that's been manually approved, that'll get pushed to production. And now we just do a hard refresh on that page. And you can see the colors changed in prod. So that's the flow for the game service itself. So the other one that I wanted to show you is the Lambda change that we made as well. So we just used, to put this together, we just used the sample code that was available. It's got a source and a build stage, similar sort of pattern. Now this time we're creating a change set with CloudFormation so that we can check and validate what changes exactly are going out. There's a manual approval stage and then the same pattern again. So you can see exactly what the different stages are. And again, having this all-in-one pipeline makes it very easy to avoid configuration drift. So just looking at the build stage, just going to edit that project and have a look at the build spec. So you can see here in the build stage, we've got the command in there to package up the CloudFormation script and store that in S3. So this is the actual Lambda code that we've got in there. And as I said, the reason I wanted to show you this is so you can see how to assume a cross-account role from the context of the Lambda function. So that's what it is. It's sts.assumeRole. And then the response, that's hitting the Systems Manager and using the get parameter command, and then it's passing that into the DynamoDB call. So that is how that's how the Lambda function works to do the cross-account stuff. So you can see that both those are pretty straightforward. If you build them and you use the right sort of patterns, it's not too hard to do. You can set it up so that cross-account stuff becomes more of a non-issue, but it's very important to have the structure set up correctly. So as part of the conversation, when you're getting this done, you need to include all of the different dev teams in this journey. Ops teams that are involved, that's very common, particularly in the big enterprise, like complex enterprise environments. Any DevOps teams, your Cloud Center of Excellence, and InfoSec as well. These all need to be part of the journey when you're setting up like proper multi-account automation, because a lot of people will have a lot of opinions on how best to do automation. So you need to get on the same page. You can't just beat people into what you tell them is best. So this is a team effort. Use a separate account for the DevOps tooling. That's a really good pattern. As I said before, keep things separate, define the security context. Dev's going to have a bunch of engineers, usually with a lot more lax security, doing all sorts of crazy stuff. You don't want that security context to be applied to your pipeline, which can then push stuff into production. Very bad idea. Use cross-account roles to coordinate your administration of these things and the different deployments. And a key tenet to this as well is to build once and deploy many times. So carry that same build artifact through, push it to one environment, test that environment, push it to the next environment. This pattern's really good for that. So if you enjoy this session, you can tap up the top of the room to get more information, and we'd really appreciate feedback as well. Hopefully this has been useful. And thanks very much for your time, everyone.